Welcome to Topic 4, Unit 2, the Law of Cosines. Now it's time to practice solving triangles when two sides in the included angle are known, SAS, or when three sides are known, SSS. We have already derived the law of cosines, and so the three formulas for the law of cosines are shown below, and let's do a couple of examples to see how it works. Example 1. Solve the triangle A equals 2, B equals 3, and C equals 60 degrees. It's always a good idea to sketch the triangle before you start. So I'll say this is A, this is B, and this is C. We know that C is 60 degrees, A is equal to 2, and B is equal to 3, and we have a missing side C. So you can see that this is a side angle side situation. So we'll use the law of cosines. So since my missing side is C, I'm going to say that C squared equals A squared plus B squared minus 2AB times the cosine of C, which is equal to 2 squared plus 3 squared minus 2 times 3 times the cosine of 60 degrees, which is equal to 4 plus 9 minus 12, and I happen to know that the cosine of 60 degrees is 1/2, and so finally we get that C squared is equal to 7, which means that C is equal to the square root of 7. Now we could use law of cosines to find angle A or angle B, but the law of sines is a little bit quicker. The catch is that you should always choose to find the angle opposite the smallest side to make sure that we're finding an acute angle and the ambiguous case does not come into play. So since the smallest side is A, I'm going to say sine of A over 2 is equal to sine of 60 over the square root of 7, which means the sine of A is equal to 2 over the square root of 7 times the sine of 60 degrees, which is the square root of 3 over 2. If I put this into my calculator, I get the sine of A is equal to 0.6546. And if I calculate the inverse sine, I get that angle A is equal to 40.9 degrees. And then finally, I can find angle B by taking 180 minus angle C 60 minus angle A 40.9, and I get that angle B is equal to 79.1 degrees. Example 2. Solve the triangle A equals 4, B equals 3, and C equals 6. So I'm going to draw angle ABC. It doesn't matter if it's to scale. A equals 4, B equals 3, and C equals 6. So this is a side, side, side situation, and I am going to use law of cosines to find the largest angle. Now the largest angle is going to be opposite the largest side, so I am going to find angle C. So I'm going to use the equation C squared equals A squared plus B squared minus 2AB times the cosine of C. So if I solve for cosine C, I get that cosine of C is equal to C squared minus A squared minus B squared all over negative 2AB. So that's going to be 6 squared minus 4 squared minus 3 squared over negative 2 times 4 times 3. And this is equal to negative 0.4583. So if the cosine C is equal to negative 0.4583, I'm going to find the inverse cosine of that number, and angle C is equal to 117.3 degrees. Now I will find angle A by using law of sines. So sine of A over 4 is equal to sine of 117.3 over 6. So sine of A is equal to 0.5925, which means angle A is equal to 36.3 degrees Finally, we can find angle B by saying angle B is equal to 180 minus 117.3 minus 36.3, and angle B is equal to 26.4 degrees. Now we've already learned how to find the area of a triangle using the law of sines, but there's a special formula we can use when we know the three lengths of the sides. It's called Heron's formula. And the area K of a triangle with sides A, B, and C is K equals the square root of S times S minus A, S minus B, S minus C, where S is the semi-perimeter. That's when we add up the perimeter of the triangle and we divide it by 2. So example 3, we're going to find the area of a triangle whose sides are 4, 5, and 7. So we'll start by finding the semi-perimeter, which is 1/2 times 4 plus 5 plus 7, which is equal to 1/2 times 16, which is equal to 8. So now when I find the area, it's going to be the square root of 8 times 8 minus 4 times 8 minus 5 times 8 minus 7, which is the square root of 8 times 4 times 3 times 1, which is equal to the square root of 96. Now since 96 is 16 times 6, this simplifies to 4 times the square root of 6 units squared. That's all for now. Thanks for watching.